So I think there is something like a okay, you have to click. That is
Yes, I
okay, okay. Thank you so much. Okay, so now we will start your BARC mock interview. We have 30 minutes. So you tell me your two favorite subjects.
fluid mechanics and heat transfer.
Fluid mechanics and heat transfer. Fine. Okay then. So we will start, Asif. Right. So first of all, you tell me, Asif, that if I have a tank here, okay, like this, and this is another tank, okay.
Okay.
So and I am joining these two tanks by a valve, okay.
Okay.
So at first, this tank was having a level like maybe H1, and this tank is having a level like H2, and both tank are having same diameter, okay. But the
Okay.
levels, but the levels are different. So first of all, you tell me that what will be the height if I open the valve? What will be the final height if I open the valve in both the tanks?
In both the tanks, the operating pressure is P atmosphere.
Yes, yes, yes. They are subjected to PAT. Right.
So in that case, that H1 height H1 will increase and H2 will decrease, and if we conserve the volume from that, we will get the value of final height, that is H, which will be same in both the tanks.
Okay, fine. So now you have to draw the graphs of the height versus time. So T versus H for both the tanks. So if I call it as tank A and tank B, for both the tanks, you have to draw the graphs.
Okay. So in case of the left tank,
You
in
draw and
case of
show
the
me.
left tank, okay.
You draw and show me. Do you need some hint or help?
No, I am fine.
Sure, sure. Take your time. See, you don't have to draw the exact, exact equation or curve. You have to just show me the nature. Okay.
Just give me a moment. I'm trying.
Sure, sure, sure. You take time.
It will be the time is I think root 8.
Hmm? You show me the graph. I don't want equation. You show me the graph. Hello, Asif. Can you hear me?
It will be and the hello. Am I audible now?
Yes, yes. You are audible.
Sorry, sorry. There is a call. That's why the network disconnected.
Also,
So as I am showing the
mm-hmm.
graph like this.
Both are having same age. So first of all, you should draw them on the same graph. You draw them on the same plot. Okay.
Okay. So is the variation correct? That is t will be directly proportional to root h.
See, I don't want to see any, equation. You have to, so okay, you answer me. That what will be the slope? What will be the slope of the curve? Will it be a constant slope or increasing slope or decreasing slope?
Uh, Slope will be the in case of the first tank, slope will be decreasing. Slope will be decreasing, continue gradually decreasing.
In case of first tank means tank A, tank A.
Tank A. Slope
Okay.
is gradually decreasing and height
And for
height is increasing.
and for tank B, what about the slope?
Same, the slope will continuously, gradually decreasing, and it will, uh, the final level will be below H2. Same, the
Below
slope will
H.
be gradually decreasing.
And why the slope is decreasing? Can you guess
Because
without any equation? Yes. Tell me. Physically,
yeah,
yes.
there is a head difference. That's why
Hmm.
actually they will try to balance the datum head in both the tanks. So
Right.
as they approaches the final level, the difference in the datum head will decrease. So that's why the slope will be gradually decreasing.
Okay. Datum head will finally decrease. That is why the slope will gradually decrease.
That the difference in between the both tanks, the difference in the datum head, that is
Hmm.
decreasing. That's why the slope will be gradually decreasing in both the cases.
Okay. Okay. Fine. Okay. So now you tell me that if I close this tank, if I close this tank, okay, and
Okay.
here
Okay.
at first, the valve was again closed, and here I am having a pressure PATM. Okay, so now you tell me that after I open the valve, now what will happen?
The same case will happen. They will try to balance, but here there will be a slight imbalance because in the B tank, as
Hmm.
the level decreases, there will be the volume will increase, and the PATM will gradually decreasing. That PATM that is initially will be there, that will in the as that H2 will go down, that PATM will decrease. So that's why there will be a final imbalance in the level.
So
But
compared
they
to
will
the
try
HF,
to.
so
Okay.
compared to the HF, compared to the HF that you, calculated in the, previous stage, the final height.
Yes.
So compared to
Yes.
the HF, now the new final height of the tank B. So will that be more compared to HF or less compared to it?
It will be more as compared to previous.
It will be more. Good. And how can you calculate that HF?
Uh, that calculate that HF in this case when it is closed.
Hmm.
In that case, because we have to know the final pressure of that upper part. So
So how
if
can you know
we
that? How
uh,
can you know that? Yes.
final pressure, we can use the ideal gas equation if it is since it is air. So using that, because we will know the volume in that upper part, since we know the initial height, and we will assign the final height as HF. So the upper part volume we will know, same mass we will also get to know, and temperature I think will be given. So from that equation uh, we can get the P2 value. So using that P2, we can calculate then the final height.
So temperature is not given, and also you don't know the final height first. You have to find the final height. That was my question. So if you don't know the final height, you will, you cannot know this final volume, right? If you don't know the final height, you cannot know the final volume. So what you are trying to say is that I will be using the, ideal gas equation P equal to 1 by V RT, right? This I have, just have written the small v. That is fine. But you are telling that the temperature is given and this V is also you know. But you cannot know this V, I mean, if you don't know the final height, right?
In that case, this 1 by small b we can write as rho also. So if we consider that the rho is not changing, since there will be a small volume difference, so using that we can
You
conclude.
cannot consider such things. You cannot consider such things if it is not given to you. In the actual interview, you have to first ask that, sir, can I consider this? So here, firstly, the temperature is not given. I have only given you, okay, Ti is given. That is the, I mean, initial temperature, but the final temperature I have not given to you. You have to find the final
Okay.
temperature also. Either you
Okay.
have to find, either you have to find or you have to tell something that, okay, this process will be this. That means the temperature will be higher or lower or will be, I mean same or will be same. Okay. Okay, so let us, okay, now for the time being you just, leave it. Now let us move to the heat transfer. Okay. So for the heat transfer, Asif, you tell me that if I have ice, okay, so if I have ice here,
Okay.
okay, and this ice is at minus 20 degrees Celsius here,
Okay.
and you have ambient at 30 degrees Celsius.
Okay.
Okay, so now you have to draw the graph. You have to draw the graph of this T ice versus time. You have to draw the graph.
Ti versus time.
Time. Hmm.
Temperature of ice versus time. With time, if it is, placed in that environment for a long time.
Long time. For a long time.
Okay. Okay. And can we consider the lump system analysis here?
Okay.
Like,
Consider. So first of all, you tell me that what is the assumption when the lump mass system analysis is valid.
so in that case, we consider temperature as function of time only. We do not consider the temperature
No, no.
as function of
When
space.
when it is valid, yes, you are telling me that what is the lump mass analysis, but I am asking that when it is valid, in which
It
case
is valid.
it is valid. Yes, tell me.
It is valid when the internal conduction resistance by external conduction conductive resistance value is very less, and we generally consider it as 0.1.
Internal conduction resistance is less compared to the
External convective resistance.
external convective resistance. Good. And what is this number that you have just told? What is this?
This number is known as Biot number, but this is a
Okay,
dimensionless
fine,
number.
fine, fine. Okay. Now you can draw. Now you draw. See, I don't need any kind of equation. You have to just draw it.
Okay.
Okay. Good. Good. So now, uh, what I am doing is, so here so now this is the case 1 and here the pressure was PATM. Okay. The pressure was PATM. Now I am just increasing the pressure. Okay.
The ambient
Now
pressure.
you draw. Yes. Now I am just increasing the ambient pressure. So now you draw the same graph.
same thing will happen. Just the phase change will not be at 0 degrees Celsius. It will be some more. I mean, greater than zero. The phase change.
For ice, the melting point, I mean, so if I increase the pressure, the melting point increases for ice.
Uh, just give you a moment to just cross check this thing.
Sure.
See the PT diagram.
Okay, Asif. I mean, leave it, leave it. So here I have one more question for you. Okay. So
Just I have completed that. I want to conclude that answer.
okay, conclude in 1 minute then.
Uh, so as this is the PT diagram I have drawn for H2O, and since this is a negative slope curve, so as pressure increases, the that I have shown that T is greater than zero, it will be less than zero.
Exactly.
It will be
Exactly.
yes.
And
Sorry for
what
the
are
miss.
okay? And what about the slope?
This slope, that curve slope,
That will be same.
that is slope will be same. Yes, slope is
Right?
about this curve.
Yes. Yes. This and the upper curve also.
The
Why the slope will be
uh,
same?
the the slope it is HA whole by VC. Uh it has nothing to deal with pressure. So
Okay, good,
there
good,
is
good.
no term of
Okay. Now I have a the final question for you. So, so here again I have an ice cube, but now the ice cube is sufficiently long. Okay. So maybe it is some L. Okay. And it is having a
okay,
constant area of, I mean, cross section. And this ice cube is insulated from these both sides. Okay,
okay,
insulated from both the sides. You can consider it as a chunk of cylinder also. Okay, so now
okay,
the ambient temperature is again at 30 degrees Celsius. So you have to draw the temperature profile from x equal to 0 to x equal to 2L. Okay, you have to draw the
x equals
temperature
to
profile.
2L. Okay, okay. The whole ice is at 100 degrees Celsius. I mean, uh,
No. This only this phase. I have told you that only this phase I have maintained here. So only this
okay,
phase
okay,
I have maintained here. Okay, a minus 100 degrees Celsius.
okay, got it.
Okay.
And heat wins from this side. Okay,
Okay. Uh, okay. So that is the, I mean, thermal boundary layer, right? That is the thermal
yes,
boundary layer. Okay. So now what I am doing is see very carefully. So here I am just taking this ice cube. Okay. I am just copying it and I will paste it here and I will do it upside down. Okay. So
okay, okay,
sorry for that. Okay. Yes. The same scenario is there, but now I have done it as upside down. Okay. Now what will happen? Now draw the same temperature profile on the same plot. Don't in a different plot. Don't draw in a different plot. You have to draw in a same graph from x equal to 0 to x equal to 2L for this inverted case.
okay,
You can draw with a dotted line to segregate.
okay. Actually, here Here the boundary layer formation will be different. Here the boundary layer formation will be different. The remaining part is same, just the boundary layer formation will be different, and that will be
Okay, so first you draw the graph only inside that, only from 0 to x equal to 0 to x equal to L. What will be the difference if I just invert the size?
there will be no difference. It will be same. Oh, just for wait. Okay. Give me a moment to think. Mm. The interface temperature. The interface temperature will be different. So there will be slight difference in the graph, but the nature will be same. It will be linear, but the interface temperature on the upper part of this ice cube, that will be different from the previous case.
What will be the interface temperature? Will it increase or decrease? And what will be the also heat flux? What will be the heat flux? Because if I have to maintain here minus 100 degrees Celsius, I have to maintain some heat flux, either some heat in or some heat out. So what will be the heat flux? Will it increase or decrease? And also what will be the interface temperature? Will it increase or decrease?
Interface temperature,
Mhm.
in this case, the heat transfer will be less. Transfer will be less.
Okay, if I consider that the heat transfer will be less, you are
Less.
telling me that that at the interface the heat transfer will be less. If I consider
Yes.
that, then what will be the interface temperature? Will it increase or decrease?
If the heat transfer is less, that means the temperature difference should be less. That means the 100 temperature difference will be less. So here the interface temperature will be less. The interface temperature will be less.
Interface temperature will be less. And the heat flux?
Heat flask is Q by A. Area is not changing. Q is changing. So heat flask will also be decreased.
So you tell me if it is steady state, so heat flux inside the slab and heat flux from the ambient to the slab, will it be same or different if it is steady state?
It will be same. It will be same.
Okay, fine. Okay, so Asik, here your interview, we have to just, end it. Now I will give you the feedback because we have only 4 minutes left. Okay. So first of all, if I start from the fluid mechanics, for the the questions that I have asked you. See, first of all, this fluid mechanics question is almost is a previous year BARC interview question. If you find is, if you search in Quora, you can easily find it. But there is one difference, that is they have closed this tank, but I have closed this tank. So I was thinking to increase the level also, but you are not rightly telling that how I can find the final height. See, you don't know the final height, and please don't take any assumptions just by yourself. You have to always ask the panelists. Okay, that can I take the same temperature? Can I take the same density? Okay, you have to ask them. Okay, so here the thing will be that if you only consider an isothermal expansion, okay, because this will be an expansion, right? So here if you only consider the isothermal expansion, then only you can take the same temperature throughout the process. Then you only know the final temperature. Then they will ask you that
Okay.
why are you, I mean, why are you I mean, considering the process to be isothermal, then you have to explain that also. Okay. So think like it. Don't think from the I mean from the point of view of equation. So this is another thing that you are again and again doing. So see, is I mean proportional to root t. If that is so, that is perfectly fine. Okay, sorry.
Yes.
I think the I mean
It is
opposite will. Yes.
opposite. Yes, yes.
Yes. So, but that is fine. But they are not asking for that. Okay, they are
Ye-
they.
Okay.
So they will be asking you that without writing any equation, you have to draw the graphs. Okay,
Okay.
without writing any equation, you have to draw the graphs. Okay, so practice like this. Build your physical intuition. कि कि अगर ऐसा होगा तो क्या होगा? Okay, like that. And for the heat transfer case, okay, for the ice case, you have drawn it beautifully. But for this case, see here what is happening? Natural convection. So natural convection means what? From this cool surface, the air is actually heated, right? And it is going up. Is it so?
Yes. Yes.
No. From this, no. See, these things you have to think. So don't say yes. See, this is a cool surface and the ambient is hot. So the hot air will come across this cool surface and that will be cooled. So then the hot air will be like this. Okay. So I mean, previously the hot air was going down. Okay. And actually you have drawn. So can you show me the picture again? Yeah, you have drawn it wrongly actually. Okay. I mean, you
In
have
the
drawn.
boundary layer part.
Yes.